Hey everybody, Mrs. Lowe here. This is our first lesson in our rational expressions, equations, and functions unit. That's what the REEF stands for. Today we're going to do a little introduction into rational expressions and functions. You're going to be able to identify the domain and simplify a rational function by factoring. Factoring. What is a rational expression? It is a ratio of two polynomials, and here are some examples. A, B, and C shows you some rational expressions. Notice they are divided, hence ratio. You should also be able to determine the degree of the numerator and the denominator, because that will be important when we're finding asymptotes and graphing rational equations. So the degree of A's numerator is 0, doesn't have a variable. The degree of A's denominator is 1 because it has the highest exponent of 1. The degree of B's numerator is 1, and the degree of B's denominator is 2. The degree of C's numerator is, if you were to expand, this would be an x cubed, so 3, and the degree of C's denominator is 1. So you guys should be able to identify degrees. What does it mean to evaluate a rational function? Well, we have done this before. We've done plenty of evaluating. So basically, you're plugging in an x value or an input value, and you're getting an output. So we're going to find g of 1, g of 0, and g of 2. It's very important that you have proper notation. Notice I replace the x values with 1. So g of 1 is 2 times 1 plus 3 over 1 minus 2. So this would give you 5 over negative 1, which is negative 5. So g of 1 is negative 5. So 1, negative 5 is an actual point on the rational function, g of x. We can do the same thing for g of 0. 2 times 0 is 0, plus 3 is 3. 0 minus negative 2 is negative 2. So 3 over negative 2 is the output. So when you put in x is 0, you get negative 3 over 2. This is a point on the function. It's also specifically the y-intercept because the x value is 0. Therefore, the function crosses at negative 3, 2. You need to do C. So when you come in, when you submit this note guide, C should be done. Moving on to domain. The domain of a rational expression or function is the set of all input values. In the case of rational expressions, we can input any value except those that make the denominator equal to 0, since division by 0 is undefined. So in other words, the domain of a rational expression includes all real numbers except for those that make the denominator 0. So we are going to figure out the restrictions to the function, and we're going to write the domain. So first thing you want to do is factor the numerator and the denominator, and you want to put those factors in parentheses. So the numerator is already factored to x plus 1, and the denominator factors to x plus 4, x minus 3. See how important it is that we be able to factor quickly and efficiently. Then we're going to determine the zeros of the denominator. Well, the zeros are the restrictions. So there's two factors in the denominator, x plus 4, which means that x could not be negative 4, because that would make this 0, and that would mean the denominator is 0. The other factor in the denominator is x minus 3, and the value of x that would make that 0 is 3. So those are the two restrictions, what the function cannot take on. So the restrictions are x cannot be negative 4 and 3. And then as far as the domain goes, the function continues to the left infinitely, to negative infinity. Then it goes up to negative 4. It does not include negative 4 because it's undefined there. Then it picks up again from negative 4 to 3. And then it picks up from 3 to infinity. And you'll see that when we graph these functions later on. So we're more likely going to be doing the restrictions versus domain, but you should still understand how to find the domain. So for the practice, you're going to factor and state the domain. You're going to do number 2 and 3 on your own, and I'm going to do 1 and 4 with you. So g of x, I'm going to factor The numerator is already factored, so I'm going to put it in parentheses. X squared minus 4. Remember, this is a difference of squares. You also see me write it as DOS, difference of squares. So that factors to x plus 2, x minus 2. You should be able to factor those very quickly. So the restrictions are negative 2 and 2. That's what would make these 0. And the domain would be from negative infinity to negative 2, then from negative 2 to 2, then from 2 to infinity. So these are the asymptotes. We'll talk about asymptotes. So the graph basically skips over those two numbers. Number 4, factoring. So the numerator in number 4 is a difference of squares. That's a perfect square and that's a perfect square. So it factors to 5x minus 3 and 5x plus 3. And then the denominator, well, you guys could do it off to the side and do the x method, but trust me that it factors to 2x minus 3 and 3x plus 5. Make sure you know how to factor that denominator. And therefore the restrictions that x cannot be, it cannot be 3 halves, positive 3 halves. I need to erase that negative. And it cannot be negative 5 thirds. Those are its two restrictions. Those are where its asymptotes will be. The domain is from negative infinity to negative 5 thirds. Skips over 5 thirds, and it goes from negative 5 thirds to 3 halves. Skips over 3 halves, and it goes from 3 halves to infinity. You guys also had to do this on your first term exam, so you should know how to do this. On the second video, we're going to get to simplifying rational expressions. Make sure you complete the problems that I circled.